Hi, I'm Darren Llewellyn. Welcome to another episode of MyToolboxTV. Today we're going to run through some Ohm's Law exercises. We already talked about Ohm's Law and how it shows the relationship to the fundamental quantities. Now we're going to run through some more exercises. Let's take a look at them. Let's look at some more examples of Ohm's Law. Here's a simple circuit, 6-volt source, and it doesn't matter if it's a battery or whatever the source is. There's 6 volts of potential energy applied to a 3-ohm resistance. There's a complete circuit. When this happens, this will cause current to flow through the circuit like this. And when this current flows, it'll flow through this resistance, and because the relationship between the voltage of 6 volts and 3 ohms of resistance, we can accurately predict what the current flow will be. And if we were to build this circuit, this exact thing would happen. Now, the formulas that we'll use for Ohm's Law here, remember the most simple one is voltage over current times resistance. It could be a circle or a pyramid. So let's look at this. If we want to know current, we divide voltage, which in this case is 6 volts, and we divide that by resistance, and that would be 3. So that gives us 2 amps of current flow. So current would be 2 amps. Now, based on this information that we have so far, because we've got 3 of the fundamental quantities, we can go ahead and calculate the power. That would be the wattage. Okay? And the formula that would be easiest to use here, there's 3 that we could use, but the easiest one to use right here is going to be voltage, which is 6, times current, which in this case is 2. So 6 times 2, I think that's about 12. So we have 12 watts. So in this circuit, when we started out, we just knew 2 of the quantities, voltage and resistance, 6 volts and 3 ohms. From that, we easily calculated the current, which was 2. And after we knew the current, we could then also calculate the power. And we could have calculated power other way, but this is the way that we chose to do it. It's a very simple way. So Ohm's Law helps you see relationships between other parts of the circuit and other quantities in the circuit, how they relate to each other, and how to find unknown quantities. Let's take a look at another one and see how it changes the circuit. Now, in this circuit, same circuit, except we've changed something. The voltage is the same, but we reduced resistance. Resistance in the earlier example was 3 ohms, now it's just 2. We're going to use the same formulas as we used a while ago. Voltage over I times R. And we're going to use the voltage times current to give us power. So when we turn on the circuit, current's going to flow. And we're going to have 6 volts flowing through 2 ohms of resistance. Remember, resistance is opposition to current flow. So 2 volts flowing through 2 ohms. We'll look at some Ohm's Law to calculate current. So it's going to be voltage, 6, divided by resistance. Voltage divided by resistance. 6 divided by 2 gives you 3 amps. Now, if you remember a while ago, when this resistance was 3 ohms, the current was just 2. Now resistance is less, so it makes sense, doesn't it? If the voltage stays the same, but we have less resistance, current goes up. So that's an important relationship. Resistance is opposition. So less opposition, more current. Matter of fact, if you took away all resistance, it would be pretty much a short circuit. And the current would go, if you calculate it, would go to almost infinity. So our current went up in this example. Less resistance, more current. So now we've got 3 amps instead of 2. What's that do to wattage? Well, the Ohm's Law relationship says that voltage times current equals power. Remember, wattage is power. So voltage is 6 volts times, in this case, 3 amps. Look at that. Wattage went up. as well. Earlier example, the wattage was 12, now it's up to 18. So less resistance means more current. More current means more power. This circuit's converting more energy from electrical to thermal because it's consuming power. Let's take a look at another one. Okay, let's look at this example. In this situation, the resistance will remain 2 as it was in the earlier example, but the voltage has been increased. We're kicking the voltage up. We're going to use the same formulas, and that is voltage over current times resistance, and then we'll use voltage times current equals power, and simple Ohm's law. So we turn on the circuit, close the circuit, we get current flow. How much current flow? Ohm's law will tell us. It says here if we want to know I, which is current, divide voltage by resistance. Voltage here is 8 volts, divided by 2 ohms, that's 4 amps. Okay, 4 amps. So from this relationship, we can see that in this kind of resistive circuit, if you increase voltage, you increase current. And the earlier example was if you decreased resistance, you increased current. Remember those relationships. What about power? What happens to wattage in this situation? Well, Ohm's law will show us the relationship. Voltage times current. In this case, 8 volts. 8 volts times the current was 4 amps, 32 watts. I just about misspelled W. 32 watts in this case. So you increase voltage, resistance stays the same, current goes up. Current goes up, voltage times current gives you wattage, wattage goes up. So in these 3 examples we've done, you can see how these things relate to one another. Thanks for joining us for another episode of My Toolbox TV. Hope you got something out of this by running through some exercises of Ohm's law, and we'll see you next time.